Welcome guys to another chapter, and this one we're looking at graphing quadratic functions. We've already gone through quadratic equations, looking at, I guess, the typical form of x squared plus bx plus c. And we're going to, just like, say, linear equations earlier on, we had y equals mx plus c, and this is always going to give us a straight line. We identified that m is the gradient, and it gives us, I guess, either a positive or negative gradient, etc. We're going to do the similar approach to this. Obviously, it's not a straight line graph, but in this case, quadratic graphs produce parabolas, which is going to be a curved graph. Either a smile or a frown is probably the best way to describe them. Okay. So this video, we're just going to look at certain features or characteristics of a parabola, and obviously the first part is the inversion, whether it's going to be upright or if it's going to be upside down. And so, number one, character, is it upright or is it inverted? Okay, so upright is going to look like a smile, inverted is going to be looking like a frown. This is determined by our value of a. Okay, so I'm going to have positive and negative there. So if we have a positive a, then obviously it's going to be a smile, and if we have a negative value for a, it's going to be a inverted or upside down parabola. Okay, so that's the first part. Number two, we're going to look at the intercepts, both the x and y. Okay, so you should be familiar by now that x-intercepts are where the graph cuts through the x-axis. Okay, so we'll call that x-intercepts there. In this case, we have two of them, one on this side and one on this side. Okay, and then what we also have is a y-intercept where the graph cuts through the y-axis. Okay, so the vertical is your y-axis, horizontal is your x-axis. Okay, so all of that kind of makes sense. Again, this particular stage with this video, just looking at the key features. We're not really solving anything at the moment, just being able to identify what they are. Okay, and then the last part that I want to touch base is what we call the turning point. Okay, so turning point is going to be, I'll use a different color in this case. Maybe we'll go with blue. Is going to be the point where the graph turns. Okay, so this graph is going down, and then there's a point where it turns around and goes back up. And the same thing is that it can go from the bottom going all the way up, and then there's a point where it turns around and goes all the way back down. Okay, so with having said that, want you to understand that there's two types of turning points. Okay, so call it TP as our turning points. You have a maximum turning point and you have a minimum turning point. Okay, so your maximum is going to be here and your minimum is going to be there. Okay, so if you have an upright parabola, if you have a parabola that it looks like a smile, the minimum turning point is the lowest point where the graph turns around. Okay, so if we have a positive a, positive A is going to have a minimum turning point, and then negative A is going to give us a maximum turning point. So basically, if you have a frown, if you have an inverted parabola, then the turning point is going to be the highest value before the graph turns around and goes back down. If you have an upright parabola, you'll have coming from the top going all the way down to a minimum value where it hits rock bottom before going back up. Okay, so there's your minimum turning point and there's your maximum turning point. Those are the three parts of the quadratic function that we're going to look at. I want to quickly look at a few examples just to, I guess, put this into practice. And again, we're not solving anything. We're not working anything out other than just identifying the different parts. Okay, so just visually, the first part I want to look at is it upright or is it inverted? Okay, and just for simplicity, I'm going to call it a U for upright and inverted for I for inverted. Okay, so in this case here, it looks like a smile, it looks like a frown, smile, frown, smile. That's also another smile, and we have two frowns here. Okay, so that's the first thing that I can already see from each of these 9 graphs. Okay, the second part, let's look at our intercepts, and this is both X-intercepts and Y-intercepts. Okay, so I know it's a little bit pixelated and grainy, but hopefully it's clear enough. Our X-intercept here, I might do just the top 3 just for reference. X-intercept here is -1 and +1. In this case here, our X-intercepts is -1 and +1 again, so these values here. In this case here, our X-intercepts are -1 and +3, so it's hitting the X-axis at those 2 points there. In terms of our Y-intercepts, it's hitting at -1. We have our Y-intercept here as 1, and then we have our Y-intercept here at -3. Okay, so there's our X and Y-intercepts. Now, the last thing that we want to look at is our turning points. Okay, so where does the point of the graph actually turn around? So what we could do is maybe look at the bottom 3 in this case. So we can see that the point here, turning point here, is equal to 2 and 0. So please make sure that your coordinates are in the correct order. Your X value is first and your Y value is next. Okay, we have our next one, which is over there. So our turning point is going to be at -1, 0. And then what we'll have here, our turning point is going to be at this point here. And looking at our graph, we could see that X value is 1 and the Y value is 4. So that's going to be our turning point there. One last thing that I probably didn't mention is our axis of symmetry. And I might just quickly switch back to the other graph or other page just to kind of highlight what that is. So we know that we have 2 axes, which is our horizontal and our vertical. Let's pick a different color this time. We'll go with orange. And so our turning point is the halfway mark of our parabola. Okay, and so our axis of symmetry, when we think of symmetry, we're splitting something in half, and the two halves are symmetrical to each other. It's like a reflected or mirror image. And the halfway point is going to be, so if I put axis of symmetry, is also the x coordinate of the turning point. Okay, it's the halfway mark. So going back to this case here, you'll be able to see that whatever our x value for our turning points is going to be the same value as our axis of symmetry for each of our graphs. Okay, so axis of symmetry here, we can see that it's going to be x equals 1. So axis of symmetry, x equals 1. Axis of symmetry with this middle one is x equals minus 1. And then axis of symmetry, we have x equals 2 as our equations for those points. So I'm hoping that helps you. If you have any questions, please let me know. But I guess we'll put this into a lot more practice as we go along further down the chapter. All right, see you in the next video.